Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Let's continue with today's lesson, subtopic 7.2, acid-base titration. Now that you have already learned about the titration curve, let's learn how to choose the suitable indicator in the titration process. When you carry out an acid-base titration, you use an indicator to tell you when you have the acid and base mixed in exactly the right proportions to neutralize each other. When the indicator changes color, this is often described as the endpoint of the titration. The question is, how do you choose a suitable indicator in the titration? When choosing an indicator, the endpoint pH range must lie on the steep part of the titration curve. This is to ensure that the pH at the equivalence point will fall within the range over which indicator changes color. For example, if you use phenolphthalein, you would titrate until it just becomes very pale pink at pH around 8.3 because that is as close as you can get to the equivalence point. On the other hand, using methyl red, you would titrate until there is the very first trace of yellow in the solution. If you continue doing the titration, you are getting further from the equivalence point. And you certainly don't want that, don't you? Both phenolphthalein and methyl red change their color within the pH range of the steep part of the curve. Let's look at some common acid-base indicators. The pH range is defined as the range over which the indicator changes from the acid color to the base color. Here are some common acid-base indicators. The first one is the phenolphthalein. The pH range is from 8.3 to 10, in which the color change is from colorless to pink. Since the pH range of phenolphthalein is from 8.3 to 10, phenolphthalein is a suitable indicator for a strong acid strong base titration and weak acid strong base titration. Why? Again, it is because the pH range of the phenolphthalein lies between the steep part of the curve of strong acid strong base titration and weak acid strong base titration. The second one is the methyl orange. The pH range is from 3.1 to 4.4 and the color change from red to yellow. If you look at the pH range of methyl orange, it is only suitable for the strong acid weak base titration. Here are some other examples of common acid-base indicators: thymol blue, bromothymol blue, and phenol red. Before I end this video, let's have a quick check on what you have learned, shall we? What is the color of the solution when 3 drops of the below indicators are added separately to water with pH 7? For the first indicator, which is phenolphthalein, the color change is from colorless to pale pink. Since the pH of water is 7, which is less than 8.2, the color of water when 3 drops of phenolphthalein is added will be colorless. For methyl orange, the color change is from red to yellow. Since the pH of water is 7, which is greater than 4.2, when methyl orange is added into the water, the color of the solution will be yellow. Next, the bromothymol blue has a color change of yellow to blue. Again, the pH of the water is 7, which is in between the pH range of bromothymol blue. Hence, the color of the solution should also be in between yellow and blue, which is green. Next, phenol red. Phenol red has a color change of yellow to red. Since the pH of water is 7, which is in between the pH range of phenol red, hence, the color of the solution should also be in between yellow and red, which is orange. That's it for acid-base titration. Bye!